This video aims to explore the theory of the cross product, drawing on important rules and techniques needed when using the cross product in engineering mechanics. The cross product of two vectors, A cross B, form a third vector which is perpendicular to the two vectors. This is written as A vector cross B vector is equal to C vector. The direction of the cross product can be found from using the right-hand rule. Imagine curling your right-hand fingers from vector A around to vector B. Then stick your thumb up in the air and the resulting vector would be vector C and your thumb would be pointing in its direction. Also note that if you were to cross from vector B to vector A, you would curl your fingers in the opposite direction. This would cause, in this example, to have a vector which would be in the opposite direction, and this would be the resultant of vector B cross with vector A. The magnitude of this resulting vector, vector C, can be calculated from the formula magnitude of A multiplied with the magnitude of B, then multiplied by the sine of the angle that is between the two vectors. To solve a vector cross product, written in the form on the screen below, a matrix needs to be formed. The matrix for vector A cross with vector B looks like the determinant of I, J, K, AX, AY, AZ, BX, BY, BZ. The first thing I like to do when finding the determinant of a 3x3 matrix is to write plus, minus, plus along the top. This allows me to see whether the leading term for the solution of the matrix is either positive or negative. Next, I highlight the term that I'm interested in, which is the I term, and then any adjacent terms which form a line next to the I, so the J and the K, and the AX and the BX. This allows me to see what terms I need to multiply together when solving the matrix. The next step would be to write out the first part of the solution to this matrix. So we take the positive I, so plus I, open a bracket, and then we go AY multiplied by BZ minus AZ multiplied by BY. Next step is to take the minus J and any factor that is next to it in a straight line. This gives the factors that I need to multiply, namely the AX, BZ, the AZ and BX. Next we take the minus J, open a bracket, then multiply AX by BZ minus AZ multiplied by BX. Lastly, we take the positive K and any factors which are next to it in a straight line. This gives me the two last factors that I need to multiply, namely the AX, BY, AY and BX. Next step is to write positive K, open a bracket, then multiply AX, BY, take away AY, BX. This is the general form for the solution to the determinant of this matrix. This would then be simplified into a form of CXI plus CYJ plus CZK by simplifying inside these brackets. There are three laws to remember when using the cross product. The first law is that vector A crossed with vector B does not equal vector B crossed with vector A. This is due to the right-hand rule, and if you were to curl your fingers the opposite direction from vector B to vector A, you would get a vector which points downwards instead of upwards. Therefore, the commutative rule that holds for the cross product is vector A crossed with vector B equals the negative vector B crossed with vector A. The second law to remember is the scaling law, and it states that vector A crossed with vector B multiplied by a scalar is equal to vector A multiplied by that scalar crossed by vector B, which is also the same as vector A crossed with the scalar multiplied by vector B. The last law is the distributive law, and it states that vector A crossed with vector B plus vector D is equal to vector A crossed vector B plus vector A crossed with vector D. Other important properties to remember about the cross product are, when crossing a unit vector with itself, it equals 0. And this comes from the property AB sine theta equals C, A being a magnitude, B being a magnitude, and C also being a magnitude, and theta being the angle between the two vectors. If we take the magnitude of I, which equals 1, sub this into the equation, know that the angle between the two vectors is 0 degrees. Put this into your calculator and you'll get 0. Another property to remember is when crossing two unit vectors which are different. We can draw up an IJK circle which looks like this. Remembering that the positive direction is with the arrow, we move from I to J, having a resultant of K, which is in the plus direction, due to us moving with the arrow. Take, for example, if we had I cross K. Using the same theory, we can move from I to K. However, we are moving against the arrows, which means it's a negative. The resultant would be a J, however, the resultant would be negative J, due to the negative which is here.